Swayam Prabha. Digital India. Educated India.
Welcome to the course on advanced machining processes. Today I am going to tell you about the chemical machining process. Now, before I really start with this process, I will like to tell you an important difference between the chemical machining processes and electrochemical machining processes. In case of electrochemical machining processes, what we are doing, that we are making tool and workpiece. This is the tool and this is the workpiece, and what we are doing, we are connecting them to the power supply, negative and positive, and flowing the electrolyte in the interelectrode gap, and as a result of that electrolysis takes place, and due to the electrolysis the anode dissolution or the dissolution of the material from the workpiece takes place. That means electrical energy plays an important role, while in case of chemical machining there is no use of electrical energy, rather we have a tool here and we have a workpiece here, and they are immersed inside the tank. Now that tank is filled with what is known as agent, and there is a chemical reaction between the workpiece and the agent. So I am going to discuss today chemical machining. Electrochemical machining we have already discussed in great detail in different lectures. So this difference you should keep in mind, so that there is no confusion between the electrochemical machining and chemical machining. So it is an ancient process being used for engraving the metals for making ornaments and other products. This is very old process as long as chemical machining is concerned. Chemical machining removes material in a controlled manner by the application of maskant and agent. I will explain what is the maskant and what is the agent. Now, the function of the maskant is that it does not allow agent to reach and react with workpiece to dissolve it by chemical reaction, while agent, it dissolves workpiece material by chemically acting with the workpiece. Now, agent reacts with the workpiece chemically and forms a new product and removes the material from the workpiece. Some salient features of chemical machining are that this is applicable for shallow depth of removal of material, maybe 10 millimeter, 12 millimeter or so as the upper limit. It is low cost of tooling and equipment, and there is low production runs. That means production rate is not very high, because lot of efforts made by operators are involved. Material removal rate is quite low, as you can see 0.1 millimeter per minute, just an example. Work and stress free removal of the material, as you can clearly see in chemical machining. There is no mechanical force, no thermal energy, it is only chemical reaction which is removing the material, hence it is burr free and there are no thermal or mechanical stresses on the machine component. Definitely complex designs can be machined or prepared on the component, or complex shaped components can be made by this particular process. Thin plates as thin as 0.005 millimeter, or you can say 5 micron, can be machined. There are various applications of this chemical machining processes. Some of them are stated here. They are successfully and extensively used in aviation industries. It is a very good process for making PCB, printed circuit boards, jewelry, turbine engine components, pressure vessel, bulkheads, etc. And chemical machining is used for production of blind pockets, or you can say it as chemical milling. Chemical blanking is also done, and it is used for production of through cavities or through holes, through slots, through complex cavities can be made by the application or by the use of chemical machining. Various materials which are commonly machined or shaped by this particular process include aluminum, chromium, copper, nickel, steel, lead, zinc. Now, for machining these different materials, as you can see here, like steel, lead, zinc, you have to have different kind of agent which can chemically successfully react with the workpiece material. Same way you have to also select appropriately the maskant which does not chemically react with the agent and workpiece both. Steps to be followed: clean the workpiece first using alkaline solution and then with fresh water, so that whatever dust or other things are there on the workpiece, they are separated out so that agent can directly react with the workpiece material. Apply the maskant coat by one of the following methods: cut and peel method, screen method, photoresist method. Maskants, as I have just mentioned, can be applied in three ways as shown over here. Now, this is a basic principle showing figure. Now, you can see here that agent is there, which is shown in this particular container. Now, workpiece is shown there where B is written. Now, this B is the area where there is no maskant, and in rest of the portion as shown by H line, that is the maskant. Now, agent resistant lining is there, the container is having agent resistant lining, otherwise this agent may react with the container and dissolve the container itself. So, you have the agent resistant lining. Now, agent container is also having, as mentioned here, heater coils or heating coils. Now, what happens by increasing the temperature of the agent, you can increase the dissolution rate or machining rate. That is why you can control the temperature of the bath in which agent is there, and that is what for heating coils are used. Now, what happens when this material, say from the area B as shown in this particular figure, is dissolved, then it remains in the area surrounding to B itself. As a result of that, the chemical reaction between the agent and the workpiece reduces or lowers down or becomes slow. Hence, the dissolved material or reaction products formed due to the dissolution, chemical dissolution of the workpiece should be removed quickly from the area where machining is taking place, and for that purpose you have here, that is agitator. Once you dissolution starts, the agitation of the agent should keep going on, so that the concentration of the reaction products is not high in the area surrounding the area which is to be machined, say letter B in this particular case. So, apply the maskant by one of the methods I have mentioned in the earlier slide, that was the either photoresist method, screen printing, or peel and cut off methods. Dip the workpiece in the ancient bath and let it be there for the desired time. That is, the workpiece you dip it and let it remain there for the desired period. Then take the workpiece out from the ancient bath after the desired depth has been achieved of the letter B in this particular case on the workpiece, and for deciding this particular time, how much time it will take, you have to conduct the preliminary experiments. With the help of the preliminary experiment, decide how much time it takes for removal of the material from the certain depth, and then once that time is over, that means the material has been removed up to the desired depth, then you can take the workpiece out with the help of the device where it is written control, and it will lift the workpiece and separate it out, and then as written here, remove the maskant layer from the workpiece, whatever is there, then wash the whole workpiece under the fresh water. Now, you can see here how to apply the maskant. You can apply the maskant by any of the three methods, but it has to be finally like this. You can see maskant coated area marked B. Mark the area B, there is no maskant, and rest of the portion has been coated with the maskant either by screen printing or cut and peel method. Now, if you take the section of this particular one at AA, then you see that the maskant layer is there in the last figure, and then here the agent will penetrate and start removing the material at these places. Because there is no maskant, so chemical reaction between the agent and the workpiece material will take place. So, it is clearly shown in the side view showing maskant film, workpiece and area to be etched. So, this kind of the masking can be done either cut and peel method or even with the help of screen printing. Same procedure is again explained for creating a blind cavity. This is the part to be milled, you can call it as chemical milling, and then part with the mask applied, you can see a layer of the maskant has been applied all around this on all the faces. Then you are supposed to remove the maskant from this area where chemical reaction is to take place, maskant from this particular area. Then you can put this part inside the ancient path, right, and after that you can see that finally the part is machined to the desired depth and the desired cavity is obtained from this. So, finished part with mask removed, and here is the mask remaining. You remove the mask from the workpiece, then you will finally get this particular part. Same procedure is again shown here for the different kind of the part. here one important thing is there, that dissolution is taking place from top side as well as from the bottom side. In other examples which I have explained to you, there dissolution is taking place only from the top side. So, you can see here is the clean workpiece. Now, dip the workpiece or spray workpiece to apply the photoresist coating, and this is the third one, photochemical machining, where photoresist is being applied, and after that negative applied to surface. Here is the negative which has been placed on the surface, and it is placed on both sides. You can see top side as well as bottom side. I will explain whole of this process later on also, but just to give the idea that in chemical machining, instead of machining from one side, you can machine from both the sides, so that the machining rate will increase and total time taken will be reduced. Now, after applying the photoresist developed, unexposed areas of the resist removed. So, you can see here these are the areas which are the from which the material will be removed when it is dipped inside the etchant bath, and you can see etched by the reagents, the material has been removed by the etchant from both sides, and you can see the cavity that has been formed over here, and this is the final part that has been obtained. So, what I mean to say here is that you can apply the maskant by any of these three methods. Your final aim is to get the workpiece of the desired shape and size in the minimum time. Now, what happens? Sometimes debonding takes place. That means you have applied the maskant, but somehow that maskant cracks or it is not properly adhered, and there is the way for the etchant to go and react the workpiece through that particular area also, and if it happens, then you are going to get the defective part, because you are not planning or you have not thought of removing the material from this particular area. Because of debonding, the material will get removed. So, one should be very careful, and one should check carefully that there is no cracking, no debonding of the maskant from the workpiece or on the workpiece, so that the material does not get removed from the undesirable area. To ensure proper addition of maskant on the workpiece, chemical cleaning is needed. This is very important point, because you apply the maskant, if it does not get adhered to the workpiece, then it will be loose, and then debonding or demasking will take place, and the etchant will penetrate through that particular area and remove the material from the place from where you do not want to remove any material. So, if debonding takes place, then stray cutting will take place. Whatever I had mentioned just in the earlier slide, if material is being removed from the debonded area, then that will be called as stray cutting, just like stray cutting in case of ECM process. Type of cleaning will depend upon or is a function of what type of maskant you are using, what is the workpiece material, and what is the depth of cut to which you are going to machine. Cleaning of porous material is definitely very difficult, because whatever liquid you are using for cleaning, it will get penetrated inside the porous material, and it is not desirable. For higher material removal rate, as I have shown you in the earlier figure, that is the figure of the setup, agitation will increase the chemical machining rate, and heating of the etchant will also increase the machining rate. However, you have to control the temperature of the temperature of the etchant, otherwise lot of loss of etchant will take place, and it will make the process uneconomical, and if you are agitating too much or heavily, that also may not be desirable. How to maintain high material removal rate is always a question mark as long as chemical machining is concerned, because it is a very slow process compared to electrochemical machining process. So, what is proposed or what is normally the practice is that filter the etchant before recirculation, because etchant is not thrown after using burns, it is recirculated as long as it can react with the workpiece material, because it is quite expensive. So, it should be properly filtered out before recirculating or before putting it into the container. Periodical addition of new etchant, because it is always getting mixed with the reaction products. So, it is always desirable that after a certain period of time, say 25% of the old etchant is taken out and 25% new etchant is added after a certain period of time. So, that will keep maintaining the strength of the etchant, so that the material removal rate does not go down, discarding some percent of used etchant. Material removal takes place in two directions. One is the downward direction and another is the lateral direction. While our objective is to have the material removal rate only in downward direction, not in the lateral direction, but it is a part of the phenomena that is taking place, you cannot avoid it. So, downward direction leads to what is known as depth of cut, and lateral direction is known as undercut. And undercut is the function of the depth of cut, each type of the etchant, workpiece material and etching time. More the etching time, more is the undercut, and we want minimum undercut, because it is going to deviate or to give the dimensions other than what you have designed the component. So, while designing the process of chemical machining, you should take this undercut into consideration. And there is a term known as H factor, and it is given by undercut divided by depth of cut. For uniform machining, do not allow gas to be trapped in the etchant rather than electrolyte, call it as etchant. Now, this figure shows what is the depth of cut. This is the depth of cut, and here is the undercut. That is what is shown over here, undercut, and this is the depth of cut. So, maskant protects the workpiece surface from chemical attack or chemical dissolution. Cut and peel method, neoprene, butyl or vinyl based materials are used as maskant. As I have already mentioned, that maskant should be such that it does not react with the etchant, and also it should not react with the workpiece material. Now, dipping, spraying or flow coating can be used, means the maskant can be coated by dipping the workpiece inside the bath, or spraying the maskant on the workpiece uniformly, or by flow coating kind of the things the maskant can be applied on the whole of the workpiece. Coating thickness varies usually from 25 micron to 130 micron. First apply to the entire surface of workpiece. Now, please note it carefully that the whole surface, all the faces of the workpiece should be masked, and otherwise it will start removing the material from the undesirable surfaces. Then cut and peel off from the area to be exposed to the etchant for machining, and that I have shown to you in the earlier slides also, that peel off the maskant from the area where from you want the material to be removed. Rest of the area or faces should remain masked, so that no chemical reaction takes place with the etchant. Accuracy usually obtained lies in the range of 130 micron to 750 micron. Machine depth in case of chemical machining depends upon etching time, and usually the workpiece obtained is tapered in nature. Just like I give you, suppose this is the hole that has been made, then it will be like this. That means it will be taper, and actually the maskant is up to this particular point, and you will get the taper. So what happens really? What happens really is that due to the undercut, the top diameter increases, while the diameter at the bottom of the drilled hole or machined hole does not increase to the extent as at the top. So you get the tapered workpiece. Dipping, spraying or flow coating can be used for application of the maskant on the workpiece surface. Coating thickness varies as mentioned over here. So you can see here that it gets tapered. Now same thing is shown over here. Here is the maskant and this is the workpiece. And now after cut and peel method or by any other method, what you do, that you remove the maskant from these areas where from the material is to be removed, as shown here, surface to be etched over there. And this should be done very accurately and nicely, because if this area where from the material is to be removed is not accurately demasked, then you will not get the correct product. And as you can see here, chemical machining, after this you come here, the theoretically material should have been removed like this, but due to the undercut the material has been removed more than really whatever is the width of this particular demasked area. And that is why you get, if you see the part 4 here, you get the tapered cavity rather than straight sided cavity, and you can see there is a certain angle of this taper that is shown over here as the theta, as the taper angle. So you can see that how really material removal is taking place. For stepped component, it is good method and good for large sized products, best production in large depth. Now for large size product, actually removal of the material like this is very comfortable compared to other methods where it consumes lot of electrolyte or dielectric and lot of time it takes. Here it becomes much easier if you can mask it correctly. Also very large depth cannot be done by this particular method. Now screen printing is the second method by which you can apply the maskant on the workpiece surface. And in screen printing, the maskant is applied only on those areas where from you do not want to remove the material. I will give you just an example. Say this is the workpiece and you can form a screen like this. Suppose this is the area where from you want to remove the material. Then what you do? You make the screen such that this is covered by the screen of say metal. Then what you do? You apply the maskant in the rest of the area by either spraying or by brush or by any other means. But the area where from you have kept the metallic pieces or the screen, there is no maskant. So what you can do? You remove this two plates, then you will get the workpiece of this type. There is no maskant over here, but at rest of the places you have applied the maskant by either dipping or by spraying or by another method. And when you put it in the ancient bath, then the material will be removed from this area as well as from this area. So this is the simple principle of screen printing. So screen printing is good for high volume production because masking rate or the time taken for masking reduces substantially as compared to the cut and peel method. However, the accuracy is low because the accuracy in this particular case will depend upon how accurately you have made the screen and how accurately you are applying the maskant. Low etching depth and large part size can be done, because screen printing is comparatively easy. So, large size parts, if you can make the screen, you can easily do the masking and chemical machining. Screen blocks of area to be machined, rest of the area is covered by masking. As I have shown here, this is the screen which is blocking the area which is to be machined, and rest of the area is having the maskant. That is why you have this as the blank area. Press the screen against the surface of the part and then roll up the maskant. So, instead of brushing or spraying, you can also use the roll which are having the maskant, and you rotate or move the rolls in this area where maskant is to be applied, so that the uniform layer of maskant is formed on the workpiece. Remove the screen and dry the part by baking or by heating. You can dry it so that the maskant sticks or adheres to the workpiece surface and no debonding takes place during chemical machining. Now, do etching and then go for cleaning. After etching, in etching again you have to follow the same principle as in case of cut and peel method, that you should know for how much time etching is to be done, and you let this workpiece be there in the etchant bath for that particular period of time, and in that period of time you should maintain a certain temperature as you have already decided about it, and agitation also should keep going on, so that you get the higher machining rate. Now, this is very important process of masking, that is the third process, that is the photoresist masking. Now, for complicated and accurate surfaces, cut and peel method or screen printing will not work properly, and for that purpose photoresist is the most appropriate process. But what one should do, that first prepare the enlarged drawing accounting for undercut, and then produce reduced and accurate master transparency or photo master film by the use of laser pattern generator. Then clean the workpiece thoroughly, that is remove the dirt, oxides, etc. from the top surface, from all the faces of the workpiece. Then apply a thin coating of photoresist, that is a etchant resistant material, and dry by baking. Now, hold the photomaster and the workpiece together in intimate contact. Throw the ultraviolet light through the photomaster on workpiece, and after development remove coating from the area where etching is to take place. So, that means you are really exposing the area from where material is to be removed or chemical reaction is to take place between the etchant and the workpiece material. Etch, strip of the residual photoresist and then inspect that proper etching has been done. Schematic representation of various steps to be followed in photochemical machining is given over here, and this is very important process and very commonly used for production of accurate parts. Now, prepare enlarged drawing accounting for overcut, then prepare the reduced master transparency, then clean the workpiece thoroughly, apply the photoresist, then dry the workpiece by baking process or heating process, hold the reduced master and workpiece together for certain period of time, but they should stick with each other, and then throw the ultraviolet light on the master or that photo master, then develop removes undesirable coating from the workpiece. That means remove the coating from the area where etching or chemical reaction is to take place. Now, rest of the process is the same as we have done in case of cut and peel method or screen printing method. After machining has taken place, after that you remove the photoresist, then inspect it, clean it, and then you get the machined workpiece, and this is the photochemical machined workpiece. Choice of maskant. Choice which maskant should be taken for the given workpiece, it depends upon which agent you are using, because agent should not react with maskant as well as vice versa. Which type of workpiece material you are using, it should be stable at high temperature, it should not have any chemical reaction or chemical effect on the workpiece. Agent changes metal into material salt or after chemical reaction, and there are various agents like FeCl3 for aluminum, copper, nickel, FeNO3 for silver, HF for titanium, HNO3 for tool steel. During the selection of the agent, various factors should be considered, as mentioned here, that the surface finish that you require on the machined workpiece, material removal rate, depth of penetration, that is also important factor to be considered, type of the workpiece, definitely the agent should be able to chemically react with the workpiece and dissolve the workpiece material, and what type of maskant is being used, because agent should not react with the maskant, otherwise you will not get the desired workpiece after machining, and it should not damage the workpiece in any way. And very important point is that agent should be available and it should not be very expensive, otherwise the cost of the product is going to be high, and in many cases that may not be acceptable to the users. There are certain merits of this particular process compared to many other processes. First thing is you get good surface finish and you can maintain good tolerances on the machine component. Also you can make tapered and stepped workpieces, I will explain in the following slides, by this particular process, and do not require, or it does not require skilled, highly skilled operators. In here it does not, it should be, it does not require highly skilled, not operations, but rather operators. Now this is very important, machining of a tapered and stepped workpiece. How will you machine a tapered workpiece? I have mentioned while this in the beginning of the talk of today, that is on machining, chemical machining, that machining is the function of the time. More time, more material is being removed. If you are giving less time for material removal, less material will be removed. So if you can vary the time required along the length of the workpiece, then you can make the tapered workpiece. I will explain it. Suppose you take the workpiece of this particular shape initially and you want to make this tapered workpiece. What you should do, you already have a control over there which will control the motion of this particular workpiece. Now you dip it in the agent path and slowly move the workpiece downward. Suppose you dip it when it is like this, I will make another figure, let us make like this, and it is filled with the agent, and you take the workpiece like this and there is a control over here. Now you start moving the workpiece downward at a very low rate, that you have to decide with the help of the preliminary experiments, and as you keep moving it, the material will keep removing. Now this particular part A is subjected for maximum period of machining, while part B over here will be subjected for minimum period of machining time. So you can see what will happen when after proper design of the machining parameters, if you remove the material from this particular part, then you are going to get the tapered workpiece like this as shown over here. That means you have to continuously give the feed to the workpiece so that it moves slowly at the design rate in the bath and material keeps moving. So you can get this one. Now you can also machine the staffed workpiece like this. Principle remains the same. What you do, you again same way, you have a ancient bath and you take the workpiece like this again, and you have the control over here, control, and then you divide, as you want 3 steps, you divide it in 3 areas. Now what you do, say this is A, this is B, this is C. Now first of all, this is the bath where ancient is there. You take this A whole of this A part dipped inside the ancient bath. This is the ancient bath. Ancient bath. You dip it for a certain period of time, say T1. So what will happen? That certain material will be removed from here, and you will get the workpiece like this over here. You will get the workpiece of this shape, and again you, after this, you remove, you dip B and A both inside this bath and let this be for time T2. So really speaking, part B is dipped for T2, but part A is dipped for T1 plus T2 time. So you will get the material or the shape of the component like this. Now you dip A, B, C, all the 3 inside this for time T3. So what will happen? A has been machined for the time T1 plus T2 plus T3. B has been machined for the time T2 plus T3, and C has been machined for the time T3. So you can control this length of the steps by controlling the time T1, T2 and T3, and you will be able to get the stepped component by this particular process. So what I mean to say, you can design the process in such a way that you can get the tapered workpiece, you can get the stepped workpiece. They may be cylindrical in nature, they may be rectangular or square, cuboid in nature. So depending upon your requirement, you can give different shapes. Now these are the examples of some of the chemically machined component. You can see the beauty, how fine the components have been machined. You can see here, this is the chemically machined component, and very thin arms or ribs are there, which have been, rest of the material has been removed from there. So you can make, and these are the very thin files kind of the, these are the files rather, not the thick sheets, and you cannot make this kind of the component by other processes so easily as by this particular process. Say you can use it screen printing or photoresist printing for these purposes, and it will not take too much time for dissolving the material by the agent from that particular area. So these, once you have prepared a photo master or the screen for these purposes, then you can easily mask the component and then put it in the agent for the pre-decided or pre-designed time, and then let it be machined, and you will get a fast or a high production rate chemical machine component. Now there are certain limitations of all the processes. Same is true for chemical machining. Only a few metals can be machined, because I have shown to you already that the agents available for certain materials like copper, aluminum, iron, etc. Now for every material and every alloy, you do not have the agent available. Especially in case of alloy, the problem will be multiplied, because different elements of the alloy will have different dissolution rate, chemical dissolution rate. As a result of that, you will not get the good surface finish of the machine component. And then there are the evolved gases, and these evolved gases will give you the non-uniform machining rate. Then they also will create the problem. It will lead to the uneven material removal and attack the surrounding equipment. That is another point one has to keep in mind, that whatever gases are evolved, they should be exhausted from the area where this chemical machining process is taking place, because this will attack the equipment surrounding to the chemical machining setup. Also, more importantly, the operators and other persons working around this setup will also get affected, because it is not a environment friendly process, in the sense that evolved gases will have adverse effect on the operator. Definitely, material removal rate is low in this particular case as compared to, say, electrochemical machining. Further, agents are usually corrosive in nature and toxic in nature. That is what I have just mentioned, that they are harmful to the surrounding equipment as well as the operator. So, all these gases whatever are evolved should be exhausted through proper exhaust system out of the working area, hence harmful to the surrounding equipment and operation. And differential machining of alloys lead to the poor surface finish. That is what I have just explained. Thank you very much.